Okay, I hope to start this discussion on numbers with some stuff that I hope is a review, such as rounding, okay, which is uh, basically you round off to a certain number of decimal points. You basically look at the next point, and if it's less than 5, you just leave everything alone and drop it off after the point that you're interested in. Or if that number just to the right of the place that you're interested in is greater than 5, then you basically you move it up one number. Okay. And again, I assume you've been doing this for years, so I won't belabor the point. But if I'm going to take these two values and round them to hundredths position, okay, that on this first one is right here, right? So 2 decimal points is the hundredth. So what I do is I look at this value right there, which is a 2. Since that's less than 5, I just drop all of these guys off, and I'm just left with 13.25. Now on the next one, okay, again, we want to round to the hundredth, so I'm going to round right there. This time I'm looking at this guy. Okay, I've got a 5 there. So again, anything 5 or bigger, I go ahead and round up and then drop everything off. So then rather than 0.01, this one will be 0.02 uh, with that rounding. Okay, so again, I assume rounding is nothing new here. Just want to be uh, complete with what I'm doing. The next is order of operations. Again, this is something I assume you've seen before, okay? And this is basically how the order in which you perform mathematical calculations of an equation. You've probably heard of like PEMDAS or what, please excuse my dear Aunt Sally or something like that, okay? Which basically means do what's in the parentheses first, do any exponents that you've got, then do multiplication and division, then addition and subtraction. So if you look at this example here, I want to start with what's in the parentheses, right? And in the parentheses, I've got a exponent. So I'm going to do that one first. Okay, so I start basically right here within the parentheses. So that's going to be 6 times 25 plus 3. Okay, now I can either do the 6 times 25 or I can do the plus 3. But of course, multiplication and division comes first. So I do this guy next, which gives me 150 plus 3. Adding those guys together, I get 153. So that's what inside the parentheses equals. So again, I did that first and then went down the order of operations within the parentheses. So within the parentheses, I have 753. Then I go ahead and add 7 to it, and it's 160. Again, this is hopefully stuff you've seen before, but that's the order in which you do things. Okay, parentheses you do first, then exponents, then multiply, divide, then addition and subtraction. Okay. One last thing, just and I believe most of you have seen this. Hopefully, you've seen this before, and that's the idea of scientific notation. And again, this is used when you've got very, very, very large numbers or very, very, very small numbers. So you don't have to keep writing all these digits or all these zeros just as a placeholder, so to speak. Okay. So the way we write a very, very large or a very, very small number is we start with a number between 1 and 10, so like 2.76 or something like that. And then we multiply it by 10 to some factor, basically telling you where the decimal point should be. So if it's a positive number, okay, you shift it to the right. If it's a negative number, you shift the decimal point to the left. Okay, so for example, if I've got 0.004694, okay, I want to move that decimal point so that I have a number between 1 and 10. So it's going to be 4.694. And again, what I'm essentially doing here is I've got that decimal point. I move it till I get it right there. Now, this is a small number, right? I'm moving that decimal point from 4.694 to the left, 1, 2, 3, as shown right here. So that's going to be times 10 to the minus 3, which will be 0.004694. Okay, and again, it's a way to write it so you can see without a whole bunch of zeros and actually using your little finger and counting those zeros what the number is. It helps with large and small numbers, giving you a size that you're interested in. Going the other way with something like this, again, 2, 3, 4, 5, 6. So this one's going to be 6. So that'll be 4.679. Now this one, again, this is a large number, so I'm going to have positive. That decimal point's going to be moving to the right. So it's going to be times 10 to the 6th. Okay, so again, scientific notation is just a good way to let you know where the decimal point is located, okay, just by giving as a number times 10 to some factor. Again, letting you know it very quickly to see, order of magnitude of how large or how small a number is based on, 10 to the big number, 10 to the minus big number kind of thing. Okay, so the one thing that a lot you may or may not have had is discussion of significant digits. Okay, and this is really important when it comes to measurements more than anything else. When we're just dealing with numbers, textbook problems, it's not a big deal. But when we talk about significant digits and measurements, it becomes very important. And it basically tells you how precise your measurement is. So again, this is the same length of wood, I guess here, measured with 3 different measuring devices. That first measuring device, I just know I have a meter stick. I hold it up to it. Okay, and what I can do is it I know it's somewhere between 0 and 1, so I'm confident. Okay, this is between 0 point some meters. Okay, now I don't want to just say it's 0 meters. I know it's between 0 and 1, so I'm confident of that 0. What I'm not confident of is the next number, and the next number I can then approximate to be 0.6. Okay, so that value is less precise than the next value, which I actually have basically this looks like 90 centimeters. So, this is equivalent to 60 centimeters. Okay. On the next one, I have every centimeter marking here. And I know based on this, it's somewhere between 60 and 70. Okay. So this time that 6 I am confident of. I know it's 60 something centimeters. Now the problem is beyond that, I don't really know. Like the next is an approximation, but I can go ahead and make that approximation, but I can't do any more than that. I get one more digit past what I know to be true. In the first one, I only knew it was between 0 and 1. This time, I know it's 60, and I'll just guess that it's 61 centimeters. Okay, now that has 2 significant digits. The top one only has that 1 significant digit, so it's a more precise measurement. Now, taking the next measuring device on the same length of wood, I can see that I'm between 60 and 61, so I know it's 60 point something. Okay, I'm confident of being 60 point something. That something, of course, is again a estimation, and I call that 60.9. It doesn't really matter. It's an estimation. It might be 60.8. Depends on your eyesight, basically. But what that's saying is I'm more confident even now. I can add that extra uh, digit, that 60.9, based on the measuring device I have. Now, here's the thing on this. Okay, it's the same. These all 3 have the same length. It's based on the measurement device that I'm using to let you know how precise that measurement is. Okay, and when I do that, you're only as good as your least precise measurement, and that's what leads into significant digits and when we add things, and how confident you can be and how precise those measurements actually are. Okay, so let's go ahead and walk through the rules for significant digits. Okay, so what is a significant digit? Well, it's any non-zero digit. Okay, so again, any non-zero digit is obviously significant. Okay, any zeros in between non-zero digits would also be significant. Any trailing zeros when there's a decimal point is significant. So let's talk a little bit about, let me talk first about the insignificance. Any leading zeros, those on the left, those will be insignificant. And then if there's no decimal point, any on the outside are not significant. So going back to my previous slide, right? Basically, this 0 in the first one is not significant. Okay, this has 1 significant digit. Again, even when I have 60 centimeters, this 0, because there's no decimal point in that, is not significant. Okay, on this guy, all 3 of these numbers are, or I'm sorry, both of these numbers are significant, 6 and 1, right? This 0 is also significant because it's between 2 non-zero digits. So 609, that would be all three of those would be significant. So again, 1 sig fig, 2 sig figs, 3 sig figs on something like this. Now, if there had been zeros after this 9, which there wouldn't have been because I don't have that, but any zero I place after that, what I'm saying to the reader is, hey, those zeros, I'm confident that those zeros should be there, and those are significant, as opposed to the 0 up here, because there's no decimal point, would not be significant. Okay? When adding and subtracting things, okay, when you add and subtract, you can only go out to the worst case significant digit. So if you only go out to the tenths, okay, you've got one measurement out to the tenths, the other one out to the thousandth. When you add, you have to round off to the tenths place because that's your best digit. When you multiply and divide, you do the multiplication or division, and then if one has 3 significant digits, the other has 5 significant digits, you have to round to 3 significant digits. Okay, and that's how multiplication and division work. So let's do a couple examples here. First, we'll talk about the number of significant digits, right? These two are the only significant digits in the first one. Okay, all those zeros up front are not significant because I could write this in scientific notation, and I could write this as 5.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, negative 7, right? And only these two digits right here are the significant ones. Those leading zeros are not significant. On this next one, all 5 of these are going to be significant. That 0, again, is the one that we're interested in, but because it's between other non-zero digits, it would be not significant. Now, this 0 that trails after a decimal point, that is significant. So all 3 of these are going to be significant. Similarly with this one, all 4 of these digits will be. That 0, because it trails a decimal point, is going to be significant. Okay, so let's go ahead and do a couple of calculations. So first I'm going to take 10.3 times 0.01345, and I get the answer 0.138535 when I put that into my calculator. However, this first one has 3 significant digits. This one has 4 significant digits, so I have to round that off to 3 significant digits. That's the best I can do, is that 3 significant digits value, which is going to be 0.139, right? So I round off to that third significant digit, round up from that 5. If I add these two together, 10.3 plus 0.01345, I get the answer 10.31345. Now, when I add, I can only go to the worst precise value out to the digits. So I can really only go out to this tenths of a digit here, right? Because even though this one goes out to whatever that is, 100 thousandths, this one is where I have to stop. So I have to round that off, and actually round that off to 10.3. So that whole second value doesn't even really affect it because the first measurement is so imprecise that I can't go any further than that. Okay, so we've done this. Okay, now we do PEMDAS, all that good stuff. So I have what's in here. Okay, and then I do what's in here in these parentheses. So I'll do these parentheses over here. We've already done this one. Okay, we do the parentheses first, and again 10.3, and then we do this guy, and we have 0.139, and what I'm going to do is I'm going to divide those two, okay, and I'm going to get 10.3 divided by 1.39, okay, and I get 74.1, and again, I round that off to 3 significant digits because when I do division, again, this one has 3, this one has 3, so when I divide those two, I also go to 3, and I get 74.1.